which use the recursion. It is the last in first out data structure. Okay, and we always insert. Inserting means enqueuing. Enqueue process is called insert or enqueue. You can term this also enqueue. Insert at the rear part, and front part we can, the front is used for deletion. Okay, that is dequeue. Deletion from front and insert at the rear end. Okay, now if we implement the queue using array, then first we have to front and rear are basically two uh, variables. Okay, that's why we have to first initialize your front and rear to -1. Okay, so this is the initial condition. Now we insert the queue at the rear part, right? Just 1 second. So this is your front part and this is your rear part. Okay, so F front is F and this is your rear R. Okay, now let the elements are 5, 10, and let this is your 15 and this is let 20. Okay, suppose we are instructed to insert an element, enqueue an element, let the element is 25. Okay, so first of all we have to increase the value of R rear so that a new cell is created. We have to create a room for the new entered element. So first increase the value of R and then enter that 25. Then enter your new element 25. So your new R, is at this position. Okay, this is the insertion. Suppose you have to delete an element. So deletion is done only at the front element. This is the single queue. In case of double-ended queue, insertion deletion can be done in both ways. So this is the front. So you have to increase, first of all you have to increase this F at this position and then delete the first element. So this is the deletion. So this is the insert function. Okay, so what is the condition for full queue? That is, your queue is full if the size of your queue, if you are using this, you are implementing this queue using the array. That's why you can define the size as max, as defined max. Here we define the preprocessor directive max with 10. Okay, size is 10, 0 to 9. So if the rear is 9, in our example, if the rear is max -1, then queue is full queue condition. Okay, and if your queue is totally empty, initial condition, then first of all you have to increase the front and rear to the 0th index. Your queue starts from 0 and ends at max -1, so that your total queue size, that is total array size, is max. Otherwise, that is, your queue is not full empty, not overflow, no, not full, queue is full. That's why the intermediate case, otherwise first you have to increase the rear. Okay, just increment the rear pointer. and then insert your value. This is your value, scanf. Enter your value at the rear position. So this is the insert function. Okay, or Komita, is it clear? This is the insert function.
Yes, sir.
Okay. Now delete. How to delete? So delete from the front end. So if what is the condition for uh, empty queue? That is, if this is the main condition, if your front is -1 or your front is greater than your rear. This is a linear queue. Your front is greater than your rear pointer. Then you can't delete anything from the queue. That's why print underflow. Otherwise, that is normal condition. You have to copy the front element in a variable, okay, and increase the front and return the value n. Okay. So this is the deletion function and this is the insertion function. Okay. So this is queue implementation using array. Now you have to implement this particular queue using a linked list. So let this is linked list. So we are using the single linked list. So first element, let the first element is 5. Second element is your 10, and third element, let the third element is 15, and fourth element is let this is 20. Okay. So you have to connect 5 to 10, next 10 to 15, 15 to 20. Okay. And as you are designing the queue using single linked list, so we know that the last node's second part is always, that is the pointer part, is always null. That's why cross null. This is null. Okay. So by definition, this is your rear and this is your front. So this entire one is your queue. So this is your queue, right? So your queue has two parts. First part is the front part. First part is the front part, and second part is the rear part. Okay, just hold 1 second. Hello, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So your queue has two parts. Okay, first part is the front part, and second part is the rear part. And your front and rear, these are basically these are two pointers. So these two pointers are of which type? Your node type. That particular node is your node structure. So struct node, and every node has two parts. First part is the data part and second part is the pointer part. Because of self-referencing, your pointer part's return type is same as struct node, right? So first of all, we have to define the node structure. First of all, define the node structure. Define the node. Define the node structure. How to define the node structure? Every node has two parts. Any idea how to define the node structure?
Struct
Okay, struct,
node.
struct node, and every node has two parts. First part is your data data part, and second part is your uh,
Struct node.
text part. So
Mm.
data part, its return type is your int, and its return type is okay. So this is the the node structure is defined, right? Now define your entire queue. So define the queue. So let the struct queue, and every queue, your queue, this is your queue, this is your queue. Your queue has two parts. First part is the front, and second part is the rear, right? And in case of uh, array implementation, these front and rear are initialized to -1. So in case of queue, it will be initialized to, for creation of this queue, these two pointers will be uh, uh, made null, right? So define the queue. So first one is your front pointer, and second one is your rear pointer. Okay, right? Now, what will be the return type of front and rear? Anyone?
Struct node.
Why struct node?
Because it returns a node which is of struct node type.
Yes. So your front is of this type, your rear is of this type. Every front and rear, basically these are two pointers. These two pointers are of type node type. It has two parts: data type, data part, and self-referencing pointer part. That's why. So first one, struct node, and second one is also struct node. Okay. So this is the define queue, and this is the define the node structure. Is it visible that queue? Is it visible? Line number 11. Line number 11 is visible to you.
Yes, sir.
Okay. So now struct queue, we define a pointer variable struct queue, because we are accessing the front, we are accessing the rear using this queue pointer, small queue pointer. So this small queue pointer, this is of type, this particular small queue pointer, its return type is struct queue. Okay, so we can easily use queue arrow front. Okay, we can easily use queue arrow rear for defining the front and rear respectively. Okay, is it clear? So return type of front and rear are struct node. So front has two parts, rear has two parts, but this is your queue. Its return type is struct queue. Okay, now we have to first define the queue. So create function. So create function, uh, inside the create function, let first of all we have to create your queue. So the argument, we pass the argument as struct queue, struct q, just like struct node, struct. In case of linked list, we have used struct node star start. Similarly, here we use struct q star q. Okay. So here we have to initialize from in line number 21. In line number 21, we have to initialize your q. So what is the initialization? In case of array, the initialization front is equal to -1, rear is equal to -1. In case of linked list, this will be front is equal to null, rear is equal to null. Okay. Now how to write the front is equal to null and rear is equal to null? We have to access front as q arrow front. Q arrow front. So we initialize front is equal to null and q arrow rear is equal to null. So this is the node. Your q is initialization. So this is your q initialization. Q initialization, right? Now you have to insert. So insert function. Okay. Similarly, you have to define the delete. So delete is a keyword here. Delete is a keyword in code block. So we have to use delete element. Delete element. Okay. So we have to expand line number 26. Insert function. So insert function, just like in linked list, struct q insert. Its return type. This function return type is struct q. Okay, and it is a 2-argument function. First one is the just like in case of linked list, struct node start. Here the first argument is struct q star q, and the second argument is your value. Okay, so let this is int n. Your value is n. You have to insert this n at the q. So at the q means at the rear part of the q, right? Now, how to insert? Let this is your 5, 10, 15, 20. This is your list. This is your queue. So let you are asked to insert 25. Any idea how to insert? This is your 25. What are the operations? Anyone? Or Komita, are you there?
So
Yes, Pritam.
Yes, sir.
so the
Continue.
next part of the 25 will be null.
Yes, so this is one operation.
And then the next part of 20 will point to 25.
So next part of this is now pointing to 25. This is another operation. So for this operation, we have to delete. This one, this one. Okay. And anything?
So make the last one the rear.
Yes.
25.
Yes. So cross this rear, and this is your new rear. Okay. So this is your first operation. This is your second operation. and this is your third operation. Okay, so what is the first operation? The next part of previous rear, that is 20. Okay, identify the data part. So next part of the previous rear is now pointing to the new node, right? Next, your new node now becomes the rear. Okay, and the next part, third operation, the next part of your new node, that is your rear, is made null. Okay, so first of all you have to create this new node. How to create this new node? Any idea?
Using malloc function.
So using malloc function. So first of all, just initialize, just write your new node. So new node is your, this is your 25. That is 25 is inserted at the data part of that new node. So what will be the return type of this new node?
Struct node.
Yes, struct node. So struct node, new node. And new node is dynamically, new node malloc. So first one is the cast type. So cast type, what is the cast type? We know that struct node star. And malloc, then byte size. So using the size of operator, you have to define struct node. Okay, and your data part, at the data part of the new node, at the data part of the new node, your n is inserted. So this is your n, second argument. This second argument is inserted at the data part of the newly dynamically created node. Okay, now if your list is totally empty, if your queue is totally empty, so you are implementing the queue using linked list. So at the initial step, so what is the initial step? Empty queue condition. So your front is null. If your front is null, let only 5 is the first node. 5. So here your front is equal to -1. Rear is equal to -1. So first of all, this 25, sorry, this 5 is the only one node. As this is the only one node, first node, so this will be your front and this will be your rear at the same position. Front and rear will lie at the same position and the next part is made null. So how to write? So if front is equal to null, so how to access this front? Q arrow front. If your front is equal to null, then just write this is your only one node. So Q, this is your only one node. So Q front is equal to new node. This new node is your front. At the same time, this new node is equal to your rear. And your front's next part and rear's next part both are same. Front's next part, rear's next part both are same because front and rear are at the same position. Your 5 is only one node. There is only one node at the very beginning. So front, its next part. So this is your Q, this is your front. Its next part is equal to null. At the same time, Q here because both are same. Next equal to null. Okay. So this is the condition if there is only one particular node. This particular node, that is this 5, is your front, this is your rear. Now the other case, that is this particular scenario, that is 5, 10, 15, 20 are there, you have to insert 25. So else part. So inside the else part, what is the first operation? Your first operation is that this is your first operation. This is the first operation. What is the first? That is the next part of the previous rear is pointing to the new node. Okay. So Q arrow rear. So we are accessing the rear element. So its next part now pointing to the new node. Okay. What is the second condition? Your second condition is that your new node now becomes the new rear. Okay. So how to write the second operation? Any idea? Anyone?
Q arrow rear is equals to new node.
Q arrow rear. Q arrow rear is equal to new node. And the third operation is that the next part of the present rear is made null. So Q arrow rear, its next part is made null. Okay. And finally Q. So this is the insert function. Okay. Any query?
Sir,
Yes.
instead of Q in the if condition, the last two lines, Q arrow front next is equals to null, Q arrow rear, that one. Instead of that, can't we write new node next equals to null above the if?
New node next is equal to null.
Above if condition.
Okay, so line number 33 and line number 34.
Sir, instead of line number 33 and 34, can't we write new node next equals to null in line number
So new,
above 30?
1 second.
Sir, above 30.
Above 30.
Yes, sir, above if condition.
Line number, I'm not getting your question. Line number?
Sir, instead of line number 33 and 34,
Okay, line number
above if
33 and 34. Okay.
Instead of them, can't we write new node next equals to null above the if condition in line number after line number 29?
Then in the else condition also we do not have to write that Q arrow rear arrow next equals to null. You are saying that, right?
Yes, yes.
I also think that.
Okay, okay, we will examine that while running the code. Okay.
Okay.
So this is the insert function. Now delete. So struct Q delete, and so struct Q Now, inside the delete function, what will be the first condition? How to delete the first element 5? We have to store this 5. We have to store this 5 in a temporary variable. Okay. In a temporary variable, let this is your PTR. We have to copy this 5 and then proceed this F to the next node. So this is our second condition. And finally, so this is your 5, and finally delete, and finally delete this 5. That is free. Call the free PTR. So how to write? So first of all, we have to create struct node, one temporary pointer PTR. Okay. Now your PTR, you have to copy this 5, your first one, that is your front, to the PTR. So how to copy this? How to perform this particular operation? So PTR is equal to front. So we are accessing the front as Q arrow front. Where 5 is copied. Just one formal line. If your front is null, and just you can't delete anything, so underflow. Otherwise, what should we do? You have to increase, you have to shift this F to the new position. So how to shift? What will be the line? Anyone? In line number 50?
So Q front equals to Q front next.
Q front. So Q front is equal to Q front, it's next. We are advancing our pointer, front pointer, and we have to delete. That is, delete means for deletion you have to call this free function. So to display the value, the deleted value is %d. Okay, the deleted value is %d. Okay, so this will be your PTR data part, and here you have to write the free PTR, and after that return your Q. So this is the delete function. Okay, so this is the insert one and delete one. Now you have to write the you have to display the list. How to display? Struct Q. So these functions return types is also Q type, struct Q. So this is your display function. So for display function, first of all, how to display? First of all, you have to set a temporary pointer PTR at the front gate, and you have to traverse the temporary pointer up to the rear. Okay, and every time you have to use a loop, while loop. For you can use a while loop. You have to uh, print the data part of the temporary pointer. Okay, so first of all, we have to declare the pointer, and its return type, obviously as this is the node, it has two parts. We have to define the data part every time. So PTR. Now your PTR is pointing, we know that how to traverse. In a linked list, you have to point the temporary variable, temporary pointer at the front gate. So PTR is equal to front. PTR is equal to front. So how to access the front? Q arrow front. Okay. Now, just one formal line. If your PTR is equal to null, or you can use if Q front is equal to null, just like here. If Q front is equal to, both are same, line number 47 and line number 60, same. If PTR is equal to null, just write on condition you can't. This is a empty Q. Okay. Just this is the underflow condition. Otherwise, what will be the line number 63? Any idea? Line number 63. You have to traverse from the front to the rear.
Sir,
Anyone? Yes.
sir, while loop can be run, and PTR next not equal to null. Till then we can print the values, data values, and
Okay.
then I mean proceed with the next. I mean then we can write PTR next equal to the next node. I mean.
Yes. So PTR arrow, according to you, you have to use the while loop, and inside the while loop, your condition is PTR arrow next not is equal to null. Okay.
Yes.
So you can modify this particular line as this way. Your PTR not is equal to rear. Okay, because while at the initialization step, your rear is made null. Okay, so your PTR, while your PTR is not equal to rear, so you have to access the rear. So Q arrow rear. So this is your condition. While PTR arrow next not equal to null. Okay, line number 63 is complete. Now inside the while, you have to print the data part of the PTR. So you have to use the printf function for printing. So just write %d. Okay, %d and tab. You can use the tab. Or you can use the tab, and just write down the data part. So the data part of the PTR. Now you have to advance. So advancing means PTR is equal to PTR next. Okay, PTR is equal to PTR next. Now when you are at the last one, so just write one additional line, otherwise the last one is not be there. So %d, and this will be your data part of your PTR. Okay. And finally, return Q. So this is your display function. This is the display function. This is the delete function, delete LE, and this is the insert function. Complete. Now we have to write down the main function. So there should be a menu driven program. You have to use the switch case and do while loop. So first of all, so inside you have to use a do while loop. So do until your while is there. This is your do while loop. So do something. So do something. What is your something? Just write your several printf functions. So inside the printf function, let insert. Okay. Insert. Then let the next printf is this is insert and our second one is the delete from the first opening gate, that is front, and last one is your display function. Okay, if we write line number 78, that display function. Okay, now you have to enter your choice. So you have to enter your choice. Just write down your choice. Enter your choice. Okay, enter your choice. Just your choice is, let your choice is %D and this is option. So you have to define the int op. Okay. Now scanf complete. Then you have to use the switch case. Switch case. So inside the switch, you are passing your operation option. So first one is the case 1. So how to write the case 1? Just enter your value. Enter your value. Let your value is in, as you declared in %D. So your value is in. So here after OP option, in is there. Now you have to call. Now you have to call the insert function. How to call the insert function? So this is your insert function. So there are 2 arguments. So first of all, Q is equal to insert. Insert 2 argument functions. First one is the Q, pointer Q, and second one is your in. Right? Or last one is break. What will be the case 2? How to write the case 2? Any idea? Line number 89. Anyone? How to delete? How to call the delete function? Pritam? Q is equal to delete LE. Is it visible? Break. Not getting any response. Okay, Orco Provo. Yes. So break. And last one is your case 3. So case 3 is just obviously display. So display just q is equal to display function. And inside the display you are passing this q. Just break. Okay. So while your option here option not is equal to or less than is equal to or not is equal to, you can write anything, not is equal to 4, just 1 2 3, or you can use less than is equal to 4. Less than is equal to is better. Less than is equal to 4. Less than 4. Less than 4. Okay. So this is the main function, right? Now inside the main function you have to first call the initialization function. That is, what is the initialization function? This is line number 21 to 24. This is your initialization create. This is the create function, create queue function, where we initialize the queue front as null and queue rear as null. Okay. And what is queue? Queue structure is front, queue contains queue, small q. It will point to front and rear. Every front and rear, its type is node structure. Data, it has two part, data and next part. So inside the main, we have to call create queue. So create queue. So queue should be queue is equal to dynamically, just node creation, queue is dynamically created. Node so I'm now running this one. So enter your choice. So let first enter your choice, enter your value. Let the value is 5, 10, 15, 20. 5. Again 1, 10. Just display 5 and 10. Enter your choice, enter your choice. So enter your so is it visible? The output screen is visible to you? So first one, enter your choice. 1. So enter the value 5. So display. The value is 5. Okay. Next, again insert. The value is let 10. Then display. So 5 and 10. Again insert 1, 15, 1, 20, and display. So 5, 10, 15, 20. So what is the first entered element? First entered element is 5. Now, as this is the first in, first out data structure, if you call the delete one, delete. So delete. So the deleted value is 5, and you have to display the third one. So 10, 15, 20. the first entered element is deleted first. That's why this is called the first in, first out data structure. Okay? This is the first in, first out data structure. Is it clear to you? Or Komita? Yes, Orko
Yes, sir.
Prabhu. Yes, Orko Prabhu, instead of struct type function, can it be done using the, yes, you can also done it in simple way. Orko Prabhu, you can do it in your own way, but the essence should be maintained, the rule should be maintained. Okay.